This lesson is on the application of vector dot product and vector cross product. Consider the following cases. We have case 1, case 2, case 3, and case 4. In each of these cases, we have vectors a and b separated by a certain angle. So for example, in case number 1, vectors a and b are separated by 30 degrees. In case 2, vectors a and b are separated with an angle of 90 degrees since they are perpendicular with each other. And case number 3, vectors a and b are separated with an angle of 60 degrees. And for the fourth case, vectors a and b are pointing in the same direction, and therefore the angle between them is equal to 0. So remember that when two vectors are pointing in the same direction, the angle will be 0, but if they are pointing in the opposite direction, the angle will be 180. Let me write that down. Having said that, let us identify which of these cases will give us the greatest magnitude for the dot product of vectors a and b. Now, how do we identify this? How do we know which one has the greatest magnitude of the dot product? So remember that if we talk about the dot product of two vectors, for example, in this case, vector a and b, so we are going to dot vector a and b. This is just equal to the magnitude of a multiplied by the magnitude of b cosine of the angle theta. Since in 4 of the cases, the magnitude of vectors a and b doesn't change because it's just the same vector a and b, the only thing that we should concern ourselves is the angle between the two vectors. So cosine theta, meaning to say whichever case would give us the greatest value for the cosine theta would mean that it will give us the greatest magnitude of the dot product. So let us look into that. So for case number 1, we have the magnitude of vector a multiplied by the magnitude of vector b times cosine of the angle between them. So in this case, that is 30 degrees. So we'll have cosine of 30 degrees. And this is equal to the magnitude of vector a multiplied by the magnitude of vector b. Cosine of 30 degrees is 0.866. Now let's proceed to the second case. Similarly, we have magnitude of vector a multiplied by the magnitude of vector b, cosine of the angle between the two vectors in the second case, and in this case we have 90 degrees. So then we substitute cosine of 90 degrees into the equation. So we will have a, b, and cosine of 90 degrees is equal to 0. So as a matter of fact, case 2 will have a magnitude of 0 because whatever a and b is, if it's being multiplied to 0, the answer is still going to be 0. So again, for case number 2, the magnitude of the dot product is 0. Moving on to case number 3, we have magnitude of vector a multiplied by the magnitude of vector b times the cosine of the angle between vectors a and b in the third case. So in this case, that is 60 degrees. Then this is equal to a, b, cosine of 60 degrees is equal to 0.5. For case number 4, we have the magnitude of vector a plus the magnitude of vector b, cosine of the angle between the two vectors. So in this case, since our two vectors are pointing in the same direction, so the angle between them is 0, since they're pointing in the same direction. And cosine of 0 is equal to 1. So we will have a, b multiplied by 1. So with this, we can conclude that case number 4 will have the greatest magnitude because the cosine of the angle between those two vectors is the greatest. In this case, it's equal to 1. The vectors that would result to the least magnitude of the dot product is case number 2 because its magnitude is equal to 0. So let us write that down. So once again, remember that if it's asking for the magnitude of the dot product or the scalar product, all you need to do is to look into the value of the cosine of the angle between the two vectors. On the other hand, if we are interested to determine which of these cases will give us the highest magnitude of the cross product, then we will apply the formula for the cross product. So recall that for cross product or vector product, the magnitude of the product can be obtained by the following equation. We have A, the magnitude of vector A, multiplied by the magnitude of vector B, sine of the angle between the two vectors. So again, this gives us the magnitude of the cross product. So to identify which case will give us the greatest magnitude, we just have to apply this law. So now let us look into the 4 cases. For case number 1, we have the magnitude of vector A multiplied by the magnitude of vector B multiplied by the sine of the angle between the two vectors. So in this case, that's 30 degrees. So I will have sine of 30 degrees. And similarly, all we need to concern ourselves with is the value of the sine theta. Whichever case will give us the greatest value of the sine theta will be the case that would give us the greatest magnitude of the cross product. We will have in this case A, B, sine of 30 degrees is equal to 0.5. Case number 2. Similarly, we have magnitude of vector A, magnitude of vector B, sine of the angle between the two vectors in case number 2. So in case number 2, the two vectors are separated by 90 degrees. So that's equal to sine 90. Then we will have A, B, and sine 90 is equal to 1. Moving on, for case number 3, vectors A and B, or the angle between vectors A and B, is 60 degrees. So we will have the magnitude of vector A multiplied by the magnitude of vector B, sine of 60 degrees. That is equal to A, B, sine of 60 degrees is 0.866. And lastly, for case number 4, magnitude of vector A multiplied by magnitude vector B, sine of the angle between the two vectors in case number 4. So in this case, vectors A and B are pointing in the same direction. So the angle between them is 0. If they were pointing in the opposite direction, the angle between them would be 180 degrees. So let us write that down. Sine of 0 is equal to, so that is going to be equal to A, B, and sine of 0 is equal to 0. So in fact, for case number 4, the magnitude of the cross product of vectors A and B in case number 4 is equal to 0. Now, having these values for the sine theta, we can clearly see that case number 2 will have the greatest magnitude of the cross product. Let me write that down. While case number 4 will have the least magnitude of the cross product. So to summarize, if we are interested to determine the magnitude of the cross product or the dot product, all we need to do is to look into the value of the cosine of the angle between them for the dot product, or the sine of the angles between the two vectors if we are talking about cross product. That's the end of this tutorial.